Spiral 16. Okay, here we go. So a lot of these questions will actually help you with your test on Friday as well. So let's start. Question 1. Find the temperature in Celsius. You can use the formula C Celsius equals 5/9 times Fahrenheit minus 32 in parentheses. So anytime you have the temperature in parentheses. Wow, I combined Celsius and parentheses and Fahrenheit, and I made parentheses. Yep. So anytime you have a temperature in Fahrenheit and you want to change to Celsius, this is a formula that you can use. So it is currently 68 degrees Fahrenheit. Nice autumn weather. Let's see what that means in Celsius, so that the rest of the world can actually know what it means. So here we go. So you're going to leave Celsius, that's what we want to find out, and 5/9. And we're going to replace the F, which stands for Fahrenheit. We're going to replace that F with 68 minus 32, close parentheses. So let's just follow order of operations. So 5/9 is going to stay. I'm going to take care of inside the parentheses, and let's just do this on the side. 68 minus 32, 36. Okay, I'm going to remove the parentheses because I don't need it. So just make sure that, just for you to know, you make a little dot there so you know that 5/9 is being multiplied for this to 36. It's a fraction times a whole number. You don't have to find the LCM, but it's easier if you actually make the 36, turn the 36, the whole number, into a fraction. Okay. Now I can multiply these two. When you multiply fractions, you multiply numerator times numerator and denominator times denominator. So on the top, or let's do the bottom, 9 times 1 is just 9, that's easy. And on top, you got 5 times 36. 36 times 5, 0, 3. 5 times 3 is, I don't know, it's 15. Plus 3, 18. That gives you 180. So you get 180 over 9, which can be simplified to 20. Okay, so which means that 68 degrees Fahrenheit is equal to 20 degrees Celsius. Okay. To find the area of a rectangle, you can multiply the length times width. So here's your rectangle. You multiply the length times width. This is the length. This is the width, going up and down. If the length is 8, and the width is 4y plus 1, write two different expressions that represent the area of the rectangle. All right, so remember, to find the area of a rectangle, you multiply L, the length, times the width. We're given that the L, the length, is 8, so let's replace the L with 8. And we're going to multiply times the width, and the width is 4y plus 1. Can't leave it like this. We're going to leave it in parentheses, because if we left it without parentheses, we would be multiplying 8 times 4y only and not 8 times 4y plus 1. So you need a parentheses. Okay. So there's one expression if you like. 8 times 4y plus 1. Okay. But if I use distributive property, okay. So I'm just going to write the property that I use here. If I use the distributive property, I come up with a different expression. It's going to mean the same thing, but it's just going to look a little bit different. So if I do the distributive property, it's 8 times 4y, 32y, plus 8 times 1 over here, it's 8. So another way of saying, you can actually say area equals 32y plus 8. You can say area is 8 times 4y plus 1. Notice that these two are exactly the same. Okay. So there are my two expressions. They're called expression 1, expression 2. Okay, exactly the same thing. They mean the same thing, but one was after I did distributive property, and the other one was prior to distributive property. This right now algebraic and algebraic something for each of the following expressions. So you should have had an algebraic sentence. I think I'm missing here. Okay, for each of the following expressions. So this one, you can say, if you're not using a turnaround word, you can say, write the whole thing. Okay. So A is going to write 3 times a number, okay, that I don't know. That's what's happening. Minus 9. Okay. If you want to use a turnaround word, you can use 9 less than 3 times a number. Okay. So remember, when turn around less than, the 9 goes to back, and 3 times the number goes to front. So either of those two ways would have been fine. B, you can say 5 times, what are you multiplying 5 times? Just k? No, you're multiplying 5 times the addition of k plus 4, or 5 times the sum, okay, of a number that we don't know, represented by k, and 4. So 5 times, parentheses, the sum of a number and 4, and that's what we have in letter B. C. Again, you can use a turnaround word, or you don't have to. So I'm just going to use it. Let's see. 4. I can't. 4 minus what? This is division, so you can write quotient. 4 minus the quotient of h, or a number that we don't know, represented by h. 4 minus the quotient of a number, and 5. Let's use a turnaround word. The quotient, so the quotient of a number and 5 less than 4. Okay. D, a number plus 4, a number increased by 4, the sum of a number and 4. So all those three things could have been just fine. Ooh, what is that? Okay, so the last one, a number cubed. A number cubed, or a number to the third power. Okay, whichever one you feel more comfortable. A number cubed, or a number that I don't know, to the third power, cubed, plus 2 times, because you're multiplying, right? What are you multiplying? You're multiplying the difference of these two things. 2 times the difference of m and 5. Okay. Notice that I'm doing it in order. A cubed, a to the third power, a number cubed, plus 2 times, there's my 2 times, and then in parentheses is the difference of m and 5, or another number and 5. Okay. Tony is heading to Office Min instead of Office to buy school supplies. He's going to buy notebooks that cost $175 each, and binders that cost $279 each, and reams of paper that cost $49 each. Write an expression that represents the total, the cost of his supplies. So his supplies, all right, let's see, it's going to be $1.75 times n, right, depending on however many notebooks he buys, plus $279 times B for binders, okay, for the number of binders that he's going to buy, and plus $4.99, and we're going to multiply that times R, depending on how many reams of paper he buys. So this is the expression that he can use, or anyone actually, who's buying these 3 items can use to find their cost. So that would be 1. Here's your expression. 2, calculate calculate his total if he decides to buy 3 notebooks, 2 binders, and 3 reams of paper. So we can use the expression. We can go to the expression and we can substitute. So $1.75, and we're going to multiply that by 3 because that's how many notebooks he's going to buy. We're going to multiply the $2.79 times 2 binders because that's how many binders he's going to buy. And $4.99 times 3 because that's how many reams of paper. So I'm replacing R with 3. So it's now a matter of finding a... fine, I don't have my phone with me. Okay, so 175 times 3. Okay, 15, 22, 525. So his notebook is going to cost $5.25. 279 times 2, or so 279 times 2. So it's 18 goes 1, 15, 5, 5.58. And $4.99 times 3, which is going to be almost $10, but a little bit less, 2 cents less. That's how many. Oh, times 3, sorry. It's going to be $14.97. My bad. Okay. And now I'd have to add all those 3. So 5.25. Remember, in addition, you have to line up your decimals. 5.558. And then 14.97. So let's see, 20 goes 2, 18 goes 1, 15, $25. And if you add all that up, he ends up spending $25.80. So this is what I would need to see on Friday if this was the question. Okay. Combine like terms using number operations to generate equivalent expressions. Okay, so this is something we did on Friday, I believe. All right, so here's your expression. I want you to create new expressions. Okay, so remember, equivalent expressions, so all the expressions that you're making after this, they are equivalent. They mean the same thing. They have the same value if you substitute for any given value of k. Okay, so they'll just look a little different, sometimes a little shorter. Okay, so one thing we can do here is use the distributive property. Okay, and to use the distributive property, we're going to multiply 5 times 2k, and then 5 plus times 12, and that's going to give us 10k. 5 and 12 is going to give us 60. 5 does not multiply with the 7k or the 9 outside, okay, because 5 only multiplies with the numbers inside this parenthesis, so we're going to just copy that down. So there we go. I just created an expression, a different one, and using distributive property, I created this expression. So can I combine? Actually, what am I doing here? It says combine like terms. So I still have more to do. Sorry. So 2, what can I do? I can use what do you call it? You can use the commutative property, and the commutative property allows me to switch these two. This goes that way. This goes this way. Okay. So 10k, and I'm moving minus 7k. Careful here. Plus 60 goes to the third spot and next to 9. Now the associative property. Okay, will allow us to group these two and then combine, and group these two and combine. So here I'm going to get 3k plus 69. That's my final answer. So at the same time as we combine the like terms, we create 3 different expressions. And even this last one, they all have the same meaning as that first one. Okay? So it was just my fault. I misunderstood what we had to do. The actual goal of this particular question is to come up with this. Combine all the like terms. Okay. If A equals 5, B equals C, B equals 6, and C equals 2, find the value of each expression. This is a substitution problem. So we're going to take the letters out and replace it with the value. So it's, remember, these 3 are related by multiplication. So it's 2 times A, which is 5, times B, which is 6, minus C, which is 2 to the 4th power. Okay, so all I did is replace the letters with the values that they gave us. And now I can, solve it. So I can actually multiply these 3 and do the exponent at the same time. 2 times 5 is 10. 10 times 6 is 60. Minus 2 to the 4th is 2 times 2 times 2 times 2. So 2 and 2 is 4. 4 and 2 is 8. And 8 and 2 is 16. I can subtract, and I believe I'll get 44. This is what I'm looking for. This one's a little bit more, but same thing. B to the second power, so it's 6 to the second power, minus AC, or A, which is 5, times C, which is 2, plus the C, which is 2 again. And at the bottom, I'm going to have B times C divided by 3. So B6 times C, which is 2, divided by 3. So let's do the top and the bottom separately. Okay, on the top, 6 squared, I can change that. It's 36 minus 5 times 2. I'm just going to leave it as 10, and then plus 2. The bottom, 6 times 2 is 12, and then 12 divided by 3. 6 times 2 is 12, and 12 divided by 3 is 4, so that's what I get. So I don't have to do anything more at the bottom. I still have stuff to do on top. So on the top, 36 minus 10, don't do 10 plus 2 because it's subtraction. Okay, left to right. We're doing left to right, so subtraction came first. So 36 minus 10 is 26, and 26 plus 2 is 28, so you all have 28 over 4, and that simplifies to 7. 28 divided by 4 equals 7. Okay, and that's B. C, let's replace again. B is 6, so it's 6 times 2 minus A, which is 5, and take all that to the second power, minus A, which is 5 to the second power. Now, inside the parentheses, we got to finish that before we raise it to the second power. Let's do 2 steps in one, okay? Inside the parentheses, we have to do the multiplication first. 6 times 2 is 12, minus 5 to the second power. Okay, and then 5 to the second power here. I'm just going to leave it alone. So again, I'm not done. So 12 minus 5 is 7, and that is going to be raised to the second power, minus 5 to the second power. 7 to the second power is 49. 5 to the second power is 25, and 40 minus 25 is 24. Okay. Equilateral triangle. Draw the triangle. It doesn't kill you to draw the triangle. All sides have the same value. So in this case, one side measures 4W plus 3, which means this side is also 4W plus 3, and this one is 4W plus 3. Okay, it's an equilateral triangle. It means that all sides measure the same length, whatever it is. So write 2 expressions that represent the perimeter. So perimeter of the triangle would be all sides added together, 4W plus 3, plus 4W plus 3, plus 4W plus 3. So that's one expression. It's a long one, it's an ugly one, but still one expression. Let's create another one. I can create another one by combining like terms. I can combine all the W's. This 4W, and this 4W, and this 4W. 4 plus 4 plus 4 is 12W, so I'll have a total of 12 W's. If I add all the constants together, I'll have 3 plus 3, which is 6, plus 3 is 9. There we go. I just created my second expression. So this was perimeter. I can do 4W plus 3, 4W plus 3, 4W plus 3, 4W plus 3, or I can say 12W plus 9. Either way, both of them mean exactly the same thing. Okay. Oh, and I'm pretty sure, just in case some of you might say that you could have also done, since you realize all 3 sides were the same, you said 3 times 4W plus 3, right? And if you realize, if you do, that would be considered a different expression. And if you did the distributive property, you end up with 12W, and 3 times 3 in here would be 9. So 1, 2, 3 different expressions, okay, to represent the perimeter of that triangle. Use a property to create an equivalent expression. Name the property as well. Let's see. 6 times 5, parentheses, times 2, remember. So I'm going to create a different expression. Let's see. I can do this. I can move 12 to the front. And I can move this 6 times 5 to the back. So I switch sides. Okay. This is this and this. This guy went to the back, and no, this one went to the back, to the front. And what property did I use to do that? I used the commutative property. Okay. I consider 6 and 5 as one piece, and then 12 as another one. Okay, so 12 times 6 times 5 in parentheses, that could have been 1. I could have also done this, 6 times 5 times 12, and which in this case I would have said I've used the associative property. Okay, so 2 different properties were used here. Here, I think hopefully it's obvious that the only property, I guess we can use the community property again. So if you could have said this, 3k minus 4, and switch places with 12. So in this case, I created another expression, and this one, the justification, would be the community property. Or the more, I guess, common one would be saying that I use the distributive property. And if I use the distributive property, I'm multiplying that 12 times 3k, gives me 36k, minus, and 12 times 4 is 48. So there's 2 different expressions. One where I switch the order, and that would be using the community property. And the other one where I distributed the term outside to every, multiplied by every term inside, giving you 36k minus 48. This one, 8n plus 9a, which of the properties can I use? Well, I think the only one I can use is the community property. The only one that I can use to create a new expression. And community property means switch the addends, the order of the addends here, and then put the 9a in the front, plus 8n. Okay, so here's my new property and the new expression, and the property I used to create that expression was the community property. Simplify each expression by combining the like terms. So this one doesn't say anything about product, just say combining like terms. Okay, so you can shade, you can put circles, you can do triangles, whatever is it that you want. So on a circle, the 8x, ax, find anything that's ax. There you go. So right away, you know what? I'll just now moving. Remember, this is minus ax. And then now I'm going to put a rectangle around anything that has a variable of a. That's 1, and that's 2. So I'm moving those 2 together. So it's going to be plus 12a minus 9a. I'll put a triangle over the constants, around the constants. 2 constants, 5 and 13, and plus 5. Remember, you're taking the sign that comes before it, and plus 13. My like terms are next to each other. I can combine them. 8x minus ax. Remember, when you only see a variable with no numbers or no coefficients, you can pretend there's a 1 here and then put that 1 there. So that really says 8x minus 1x, and that's 7ax. And here is 12a minus 9a, which gives you plus 3a. And 5 plus 13 is just simply 18. There's nothing else I can combine here, so this is my final answer. Okay. So at the bottom here is the same thing, except that, you know, your lovely teacher here wants to make your eyes hurt while looking at all these variables with different different exponents, but it's the same thing. So let's look for anything that says K2M3. So I'm going to circle that. I'm looking for K2M3, and I found one right here, and it's a minus sign. So let's move those and put them together. So it's K2, 3K2M3 minus K2M3. So those are alike. Let's look for K3M2. And I'll put a rectangle, K3M2, and this is a K3M2. So these are nicely next to each other. So it's plus 8K3M2 minus 4K3M2. And finally, the last guy over here, he's alone because there's no other K3M. All right, so my like terms are next to each other. These 2 are alike, remember. If there is no coefficient, you can add a 1 here. So that really says 3 minus 1, which is 2. 2k to the second power, m to the third. 8k3m2 minus 4k3m2. We can subtract this, and that gives you 8 minus 4 is just plus 4k3m2. And this last guy adds with no 1, so he's going to be copied down again. And that's my final answer. All my like terms have been combined. Okay, I ask you that you circle the like terms, put squares or rectangles around the other ones and triangles, okay, and then move them around. Okay, I will ask you to do that on the test. Okay. And we have two more. Now, find the prime factorization of 720. I'm writing an explanation form. Okay, so remember 720. Break it up into, let's see, I think it's easier if you just go 10 and 72. 10 is not prime, so we can break it up more. 2 and 5. 2 is prime, so is 5, so we can circle both. We know that's over. 72, 8 times 9. 9 is going to be 3 times 3, so I can circle them now because they're both primes. 8 would be 2 and 4. 2 I can circle. 4 I can continue again, which is 2 and 2. And I'm going to circle and circle. So 720 can be written, there's how many 2's? 1, 2, 3, 4. 2 times 2 times 2 times 2. There's a couple of 3's, times 3 times 3, and finally times 5. Exponential form, you'll lose a point if you don't write it. Rewrite that as 2 to the 4th power times 3 to the 2nd times 5. That's what 720 is written, okay, as a product of its prime numbers. To make orange juice, Sam uses 4 parts orange and 7 parts water. So let's write that as a ratio. So here's Sam. So 4 parts OJ and 7 parts water. Andres, he used 7 parts OJ and 13 parts water. So who has the stronger orange juice flavored juice here? Okay, as it is, I don't know, because 4, it's a little bit more than half of 7, and 7 is a little bit more than half. They're both about a little bit more than half, so very hard to compare in this. I would probably ask you to find a common denominator, I guess, in this for this one. So let's go and find a common denominator between 7 and 13. Between 7 and 13, I'm just going to multiply 7 and 13. 7 times 3 is 21, goes to 91. So here's my 91. I'm going to write 91 for both. So water. So how does 7 become 91? Times 13. So I'm going to multiply the top times 13. And 4 times 13 is 52. So if you gave Sam 91 parts of water, she would use 52 parts of OJ to make her juice. Let's see what happens to Andres. So Andres, 13, we changed it to 91. It was a times 7. So I'm going to multiply the top times 7. And 7 times 7 is 49 parts OJ. So if we gave Andres the same amount of water, which was 91, he will use 49 parts of OJ. So we can tell that clearly the stronger flavor here is Sam. Okay, she uses just a little bit more of OJ given the same quantity. Okay, and why is it so short? Am I missing something? All right, that's it. Okay.